wait until Andy walks by? That's my dad. It'd make the rest of our relationship kind of weird. Hi everyone, welcome back to Munro Live. I'm Julian. I'm joined today by my colleague Antonio Dineno, and we're going to be taking a look at the Lucid Air Grand Touring Battery Pack. We've gone through and fully disassembled this down to the module level, so we'll start at a very high level, talk about the differences between the pack itself across Lucid's different trim levels, and then go down into their module level architecture and some of the unique features that we found during our teardown. To start off, this for the Lucid Air Grand Touring is a 22 module battery pack with 19 of them on the base level, with what we'll go into a little bit later are 3 second level modules that are next to the power distribution units that they have at the front and the rear. One thing that is unique that Lucid does as part of their space concept is for the Air and for the Touring Edition trim levels for their vehicle, instead of a 22 module pack, they have an 18 module pack. And effectively, if we're looking at the pack here, this being the front, this being the rear, they will eliminate 4 modules from this section of the pack, which will effectively give the rear occupants more space in the footwell, while also maintaining approximately 92 kilowatt hours of battery pack capacity. Stepping up from that to the Grand Touring, which is the version that we tore down, is the 22 module pack, which is 112 kilowatt hours. Then the arguably most unique thing Lucid does with their battery pack is then for the Grand Touring Performance and their Sapphire trim, they maintain a 22 module pack, however, leveraging an identical form factor 2170 cell with a change in chemistry, they are able to achieve 118 kilowatt hours of pack capacity while making no changes to the overall form factor, packaging, or architecture to the pack, which is first that we've seen for production EV. So going into the details of the pack itself, we have here one of the initial things you'll notice just looking at this torn down with the modules removed is that we have a composite base, effectively a floor for the battery tray itself. This has a marking that's actually somewhat difficult to see, but it is embossed in the resin itself toward the front of the vehicle. And it's EPGF71, so effectively it's an epoxy glass fiber composite, 71% glass fiber fill. So the remaining 29% would be the epoxy portion of that. On top, we have a series of castings, both in the rear, effectively the mid-pack, and then to the front, which form the some of the main structure, and then the outer side sills, as well as the remaining lateral cross members, are all machined aluminum extrusions. So to the outboard side, they're identical, left hand to right hand, and effectively sandwich. And I think, Antonio, we can move this to the side here. And actually, the way that this is installed, if you can see here, Eric, is when installed, this extrusion actually fits over and captures the composite base, and then there is structural adhesive applied to help retain that. So in essence, to attach these side rails to the base itself, there are no fasteners to hold it on. It's strictly just a overlapping fit with some structural adhesive.
Speaking of structural adhesive, how would you rate this compared to the other teardowns we've done?
In terms of the other teardowns we've done, so we obviously are looking at this with the pack opened up. There was a good amount of structural adhesive holding the entire pack together. What you can't see here, and what we do actually have part of, I believe, off to the side, Antonio, is part of our lid structure. One of the other things that makes the Lucid architecturally unique is the quantity of lids that it has. So in opening up the pack, we have a series of actually 3 different SMC or sheet molding compound lids that are effectively large thermoformed sheets that fit over the top. So here is where an access panel would be for the rear power distribution unit with a module packaged underneath. Actually, I believe this would be at the front, I'm sorry. Then we have another one sort of extending off of this, moving down the spine of the battery pack, and then one more in the rear that then covers the 2 modules we have on that second layer we talked about earlier. Once you get those removed, you have access to those 3 modules, the power distribution units, and then you have the thermal management system accessible, which is this large nylon hose and line assembly with quick connects. There are actually 2 of these, one of them serving as the supply, the other is the return for the coolant. Those run on top along the center of the pack. And below this, it interfaces directly with the cooling plates, which are on top of the modules. But once you remove these cooling lines, you then have another 2 stamped steel E-coated lids that need to be removed, one of which covers the rear of the pack, which is going to actually fold over on the inside of this casting. You can still see the adhesive, the butyl here from where that was applied to seal it out. One of those lids covers the rear section of the pack. The other one will then cover the remaining front section of the pack. Those need to be removed as well, which is a combination of threaded fasteners and the adhesive here, so we had to pry that up. Then once all 5 of those lids all collectively are removed, you then have access to the pack as we see it here with just the modules bolted in place into the onto the floor of the pack.
This episode of Munro Live is brought to you by Exter. Exter makes wallets, bags, and accessories that save you time so that you can get back to living. Here at Munro, we travel often, so having Exter's Parliament wallet is great for quick and easy access while on the go. Made from environmentally certified leather, this wallet holds up to 12 cards, all easily accessible with the click of a button. For a slimmer profile, try out Exter's aluminum card holder, which features an expandable metal backplate, allowing you to carry more without adding bulk. You can travel worry-free with the addition of RFID protection to prevent wireless theft. Add on one of Exter's tracker cards to any wallet to make your wallet unlosable. With Father's Day coming up, now is the perfect time to add on an extra cash clip for Dad. This streamlined design allows maximum storage and is made to last. Save up to 40% off Exter's best sellers with their Father's Day bundle using code Munro.
Antonio, did you have any feedback or any thoughts of just the teardown process of this?
Oh, I remember it was quite difficult getting these intermediate members off. Even the side pieces took a lot of effort. These structural adhesives are not to be underestimated. But it's polarizing compared to like the 4680, where the structural adhesive was the entirety of the modules.
Right. At least with this, there is, not to say that this is a serviceable pack. I think that everybody involved in the teardown would certainly be of the opinion that in terms of serviceability, this that very likely is not part of Lucid's strategy here, given that you can only access 3 modules on the top level while effectively destroying the SMC lid components in the process of doing so. That and the coolant fittings themselves are fairly sensitive, and we did end up damaging most of them upon removing them from the cooling plates. One thing in terms of the overall structure of the pack, and speaking to how we had to remove all of these cross members via the structural adhesive, again, what's not really clear from the way that it's laid out is the main positive and negative bus bars that we had running along the length of the pack. Actually, this end was over here. These ran along the center spine of the pack itself, and you can see that between the casting and the extrusions, there's a channel that's been machined, and that was actually to capture the bus bars underneath all of this. So in order to even just be able to remove the main positive and negative bus bars, we had to remove all of these lateral cross members from inside the pack. And that's fairly atypical because with certain vehicles like the Rivian R1T, the Tesla Model S Plaid, those battery packs had the main positive and negative bus bars clear and present, laid on top of all the modules, which made it fairly easy to remove those and effectively isolate the pack and start to get it down to a module level isolation. So again, in terms of serviceability, not that you would hope to need to service one of the main bus bars, but it's captured and it's quite a lot of effort and quite a lot of time to be able to remove those. So then from the main positive and negative bus bar, another thing that stood out was the way in which they are linking the modules together. So we have here a stack of bus bars that linked each module to module, and they did so along the side rails. And you can see that we have machined slots or holes in the side, and what that effectively allows for is tool access. So this would lay flush against the top of the battery module on top of that cooling plate. You would then be able to access the holes for fastening these bus bars in place through these machine slots, and then this butyl is applied, and this is actually also where they are placing the pressure vents for the pack in a venting scenario. Something that we were able to theorize during the teardown was there's also, it's maybe a little easier to see on the backside here, Eric, but there's an alternation in where there's a slot cut into each one of these holes. Sometimes they're on top or on bottom, and that actually, from what we've been able to determine, is an assembly aid, and the upward or downward facing orientation of that slot is able to denote the polarity of the module at that point. And that's something Antonio can go into as we get into the module architecture a little bit. But then one last thing that I would like to make a note of, and Antonio's got it there, one of the downsides of Lucid's execution with having a casting separating the pack effectively into two separate areas instead of having a single lid closing out all of the modules under one roof essentially, is that you then, as opposed to using a smaller bus bar that would be able to jumper from here to here in a simple U shape, you now have to route up and around through a special channel cast into the casting. And something like this, as a single piece stamping, is going to be incredibly difficult to nest. And this is a geometry like this is ultimately going to drive up piece cost because it's a very large area and you're not utilizing very much of it. Whereas the smaller U-shaped bus bars don't take up much space, and these can be nested fairly easily within one another in a sheet stock, which ultimately makes the piece cost a little more attractive.
Right, it's charging up a lot of cost because of the amount of offal you would have on that stamping.
Right. So that about does it for the high voltage architecture overview. So Antonio, if you want to take us into the modules themselves.
All right. So Rawlinson went into some detail about his modules before, but what we get to do is actually take the whole thing apart. So we pull them out, turn them over, and we get to look at the wire bond strategy, the the current collector strategy, and even the voltage monitoring system. So the interesting thing we noticed with this is the wires have different sizes. So if you look at the bond that goes to the middle of the cell and the bond that goes to the sides of the cells, they have different thicknesses. Rawlinson said this was for the necessary voltage actually needed to blow the fuse. I think it might be, it's a good idea, but when it comes down to actually purchasing and BOM cost, bill of materials, it probably seems like a cost increase. Not sure if there's a net gain from that though.
Yeah, it's a fairly minor change, but certainly the theory behind it is not something new. I know just even with the 4680 pack, we did actually recently take another look at that and were able to actually see where they were fusing into the bus bar connections. So that's more at a high voltage level. This allows it to be done more at the cell level in the event of overcurrent, overcharge, something to that effect. So it's a minor detail, but it's certainly unique.
On the side, we have the battery monitoring system. So underneath that little protective cover is the actual board. What's unique about this is it's probably the largest board we've ever seen. And it's not exactly the largest module we've ever seen. So there's a lot of actual real estate being used to monitor a system that maybe could be done more efficiently, but they have a resistor for nearly every cell and a circuit for every brick as well.
Yeah, so just for reference, this is a Model 3 Tesla Model 3 BMS PCBA, which physically, in terms of both size and quantity of cells, is quite a bit bigger than what we have on Lucid. So to Antonio's point, there is a fairly large footprint allocated for these PCBAs.
Another unique feature about this is that there's 2 different boards for the entire pack. So this is an A board. We have a B board as well. Pretty much identical. The only real difference that is noticeable is if you turn them over, the traces are backwards.
And to the point about the A board and the B board, do you want to elaborate a little bit here on the difference we have with the A module type and the B module type? I did touch on it a little bit with the assembly aids and the side rails.
Good point. In the actual bonding of the module, they are nearly identical except for the A and B ones, where the positive and negatives are flipped on a B module. So whereas this one has your negatives going to the current collector, the other module would have the positives going to this one. So it's a way to keep the polarity to series system going, so the overall voltage adds up to what they're aiming for.
And that effectively allows Lucid to have a common module architecture, common module components. Changing up the wire bonding allows it to be a very flexible design, but this also means that they don't have to physically alternate the modules as they move along. They can keep them in the same orientation, and simply by changing the way that the wire bonds are done, they can package it much more efficiently and allow the positive and negative series connections from module to module throughout the pack.
Right. And we actually did tear down a module all the way to the cell level, and we tore up the cell as well. But when you get inside, each of the modules was broken down into 10 sections with 30 cells in each, so 300 cells per module. And they were loosely adhered to this plastic substrate on the coolant plate. So to remove the cells, compared to like the 4680, which was a structural adhesive, this is also a structural adhesive, this was very easy to remove. It almost peeled off. Which brings me to the other interesting observation, is that this pack had no potting system. The cells were just free floating in air with the adhesive and the mica sheets separating them from the bricks next to them. So that is a unique feature. It brings up a question: is potting needed in these modules? You don't really see it in pouch cells. You don't see it in cylinder or prismatic cells. This is the first time we've not seen it in the cylindrical cells.
Right.
So that'll take some engineers back to the drawing board to see if they actually need these systems. Maybe drive cost chains, or maybe it'll drive other people to put more potting in. Maybe that's a legislation thing where we need safety protocols.
Right. And yeah, just to expand on that a little bit, Antonio, the fact that there's no potting in this module was certainly a surprise to us. In the tech talks that Lucid had done, they did have a module open, and it was our assumption that we effectively were looking at a module that was before potting was installed, so we could see the contents. So opening it up to find that effectively all they have is these thermoformed mica sheets separating the parallel groups of cells as their only real thermal mitigation strategy intra-module was certainly a surprise. However, that is going to enable 2 things, and that's going to be, depending on the kind of material you're using for the potting, a massive weight reduction, potentially, because in some cases, like with the Tesla Model 3, and you have silicone-based thermal interface material, or even like with the Ford Mach-E and the Lightning, they have a similar material that's interfacing between the cold plate and the cells. But then cost is going to be another huge impact, because that is not inexpensive material. You also need space on the floor and the equipment, the capital expenditure to be able to apply and install that potting. But then another thing in what they did do, and this is actually very similar to what we saw on the Hummer, is this mica sheet is installed between each set of cells that's in parallel. So each void space here will be the array that's linked in series as the module builds up its voltage internally. And that's something that in the Hummer we saw between every 3 Ultium cells that were packaged together. We had a very large, thick kind of excessive seeming separator for thermal isolation and electrical isolation. So that is also something that we seem to be seeing more with these 800 volt architecture packs. Is inside the module there seems to be more design consideration for isolating the bricks of cells effectively, so you can mitigate your voltage losses in the event of any cell damage or anything of that nature.
And as you were saying, the higher end module brands of their vehicle are going to have a higher mileage. So this is a 4.8 amp hour cell. So there's a 5.2 amp hour cell out there as well.
Right.
They're probably using in that chemistry.
I believe when we ran the numbers, they were using, at least by our approximations, it seemed like for the base model, so for the the Air Touring and the Dream, they were using the same cell here, which is the 4800 milliamp hour cell, and then to step it up and get their enhanced range with the 22 modules in the Grand Touring Performance and the Sapphire, they were using it at the very least, 5,000 or 5200 milliamp hour cell.
The last thing I really want to mention is the module itself is a single injection molded piece with inlaid current collectors. So while this is a very complicated part, it saves on a assembly system that would be very complex in comparison to, let's say, the Hummer or even the Tesla modules, which have the bandoliers, the clamshells, and hold everything together structurally. This is a single piece done in one shot.
Yeah, the integration here is very nice. We see a very similar strategy in terms of the main current collectors that the wire bonds are jumpered off of. This is very similar to what Rivian did with their 2170 cells. However, the integration of that into an injection molded component and the fact that it's not just a carrier for the current collectors themselves, but it is the entire housing for the module and incorporates the flanges with the compression limiters for actually anchoring and mounting the modules to the pack itself, is very elegant and very well done, and that takes a lot of assembly operations and a lot of cost out of the component.
And even when I compare like the disassembly of the Rivian module, that was a painstaking process because the polycarbonate overlay on that one was a separate piece. We each had to break off piece by piece, whereas this entire thing came off pretty easily once we got the cells out. So it is a assembly aid for sure. It has positioning features inside for the cells, so they can't really tip over. The adhesive is applied, and then the cold plate is applied, and they're not really going to move. So it's another one of those things that engineers are going to go back to the drawing board and say, is this something we can do?
Right. And just one last thing I want to touch on before we wrap up with the overview of this pack is, again, something we've mentioned and I don't think we've explicitly spoken about thus far, is the actual cooling plate itself. Something that's been advertised by Lucid quite a bit in their tech talks is the location of this, which is on top of the module. So as this is currently sitting inside the pack is how it is situated when the pack is fully assembled and in use. This is a fairly atypical execution. We typically, for cooling plates, see them mainly with pouch or prismatic type cells, and those are typically located beneath the cells. And then in the case of Rivian, which is one of the few we've seen with a cooling plate in conjunction with a cylindrical cell, they had them mounted in between with no, all of the tortuous path and the dimples were between two flat surfaces so that the cells could be mounted to the top and bottom. So this just being located on top, it's a very simple way to do the cooling. There are trade-offs between if you do something like Tesla with the serpentine micro-extruded channel versus a cold plate. Cylindrical cells have anisotropic heat transfer properties, so axially and radially they'll have different rates of heat transfer, and it really just depends on, for something like this, you're able to expose one flat surface of the cell to the cold plate and you get greater heat transfer through that reduced cross section, or you have the actual serpentine cooling, which would effectively have the same profile as this, and you're gaining surface area, but at a lower available rate of heat transfer. So there are trade-offs. It ultimately comes down to how well tuned your manufacturing process is, how repeatable it is, and how effectively you can get adhesion to the curved surface of the outside of the cell as opposed to the flat bottom to a flat stamped piece of aluminum. And then the other trade-off there is whether or not something like this, whether it's on top or bottom, is going to eat up Z height in the pack.
Right.
And this is still an incredibly narrow pack, even with packaging upwards, but a consideration you need to make is in order to have the cooling going between the cells, you are then going to expand out in X or Y, which means that either the pack length is going to need to grow or you diminish the number of cells you can have in a module if you want to keep things constrained within the same box dimensions.
And I think that's something that Lucid has done to an extreme is space utilization. They drove up their kilowatt hours per liter to the extreme to fit as many cells in here, to fit as many kilowatt hours, to fit as many amp hours.
Yeah.
To increase their mileage on their vehicles as much as possible.
Yeah.
And we see that in the rest of the vehicle as well.
Right. Yeah. Volumetrically, this and even the Hummer, to an extent, were very impressive in terms of their volumetric efficiency. But yeah, Lucid absolutely, and that's a philosophy that extends out to their entire vehicle. Jordan did the hoist review for the vehicle when we first got it in. Elsewhere, even with the EDMs, just everything about the vehicle was, the philosophy seemed to be make everything as condensed and tightly packed as possible. But ultimately, I think it was done very well. So I think, Antonio, do you have any closing thoughts about the battery pack before we wrap up?
No, that's about everything we've seen, and I mean, we could go on and on for this about this because there's a lot to talk about. Yeah. But we hit all the main points, I think.
Yeah. So this was very interesting teardown, and if there is any interest for further information, we do sell reports on these battery packs, Lucid and the Hummer. So that would be available through sales@leandesign.com. But for now, I think that about wraps it up. So thank you for watching, and we'll see you around.